Okay, now we're on topic 3.1, pyramids and nets. And I want you to see how they are, we're going to learn how they're different, the pyramids and the prisms, the ones we've done before. If you look at this one and you fold on the dashed lines and you fold this up, this actually makes a triangular prism. If you look at the next one and you fold this one, these are going to all come up in one point, and this one has a square base, so this one's called a square pyramid. And that's turning a net into these three-dimensional shapes. Let's look at the diagram below where we're going to label the parts to a net and one that's drawn in 3 dimensions, or looking to be 3 dimensions. This triangle up here is called the lateral face. This little point right here is a base edge. Actually, it's a vertex. Wait a minute. Okay, I guess that's pointing to this one. This right here, the square in the middle, is called the base. I think I'll use a capital letter because that's what they do when they put it in a formula. You're going to see capital letters, and that's always going to be a formula for the base area. But that's the base. This right here, when you fold it, is called the slant height. And this right here that's pointing to this edge is the lateral edge. Now let's label some of the things here. This up here is called the vertex. This one's the slant height. And the one in the middle, the dashed line that's coming up from the center, is the height. And you don't see it on a net, so let's write that. It's not visible on a flat net. You won't see it on that, but you will need to use it when you do volume, so we'll talk about that a little bit later. Okay, let's add some similarities of prisms and pyramids. When you name a prism or a pyramid, you name them by their bases. So let's put that as our first little bullet. Both are named by the base, whatever the shape is. And on this page, that first one had a triangle for its base, so that's why it was named a triangular prism. And I'm going to show you some different ones in just a minute, but they both have the same number of lateral faces. As the base does sides. So if the base is 5 sides, it'll have 5 lateral sides. If the base, like our example up here, the base has 4 sides, so there's 4 lateral faces. Okay, let's look at some differences. In prisms, a lateral edge is the height, but not in a pyramid. And I'll show you an example of that in just a minute. Another difference would be that prisms have 2 bases, and pyramids have only one. They only have one base. Another difference is that the lateral face, prisms lateral faces are rectangles, and pyramid lateral faces are triangles. Let's see, the last thing is that pyramids have slant heights, and that's used for finding area. And you're going to learn that a slant height is always longer than the height coming down from the center of your pyramid, and I'll show an example of that. Okay, let's go to the next page. Example 1. Determine whether each net will form a pyramid when folded to make a solid. Now this one you're going to have to kind of look at and think of it folded up into a three-dimensional shape. And I do have some of these they're behind my desk, and I can show you. We can fold them together if you're having trouble seeing these folded up. Look at this first one. On this first one, there are triangle faces here. These are the lateral faces, and if you count, there's 4 of them, and there's 4 of these that would wrap around this edge right here. So this is going to be a pyramid, and because the base is a square, it's called a square pyramid. Okay, look at the next one. The base on this one would be a hexagon. It's got triangles here, so we know we can count them, and if you count the triangles, there's only 5, and there's 6 sides. So this would not make a pyramid. They need at least one more lateral face. Let's put that on here. You need another lateral face. Alright, this next one, because it's got a triangle in the center, that means that's the base. It's going to be a triangular pyramid. This will make a triangular pyramid. On example 2, they want us to actually name the vertex, the faces, and the edges. So let's look at the first one. The vertex on this one is the point where the lateral faces come together, so that would be point E. In geometry, all points are labeled with capital letters. Now the lateral faces are actually the 4 triangles that are coming up to that vertex point. So the symbol for a triangle is a little triangle. So let's name, how about the front one? The front triangle here is AEB. Let's go around to the right. The next triangle would be this one right here, would be EBC. Doesn't really matter the order of your letters, just make sure you name all 3. The triangle in the back would be DEC, and the one on the left side, is triangle ADE. Those are all the lateral faces because they're the triangles that are coming and going around that base shape here. The lateral edges are the ones that include the vertex point, but they start at the base. So there are going to be segment AE is a lateral edge, segment DE is a lateral edge, BE and BC. Oh, I'm sorry, BE and CE. I said that wrong. Those are all the edges that come up to the vertex E. Now the base edges are the ones that create the base, and that base would be down here. So the base edges are AD, AB, BC, and DC. Those are the 4 edges that make up the base of this. It's probably a square pyramid. I think those are the next 2. Yeah, we're going to deal with some square pyramids here. Look at example 3 when it wants you to find the slant height. If you look at this picture, the slant height, I don't know if this will show up. I think I'm going to color it red. The slant height is this line that's coming down from, I don't know if you can tell what I just did, but I made this a little bit darker. This right here is called the slant height. Okay, because they've only labeled one side, I think I'd like to add to this, find the slant height of, let's write, of the square pyramid. Because if it's square, they only have to label one of the sides, and the other sides will also be 12. Now, I want you to notice that the height is from the center of this square, so the distance across from the center to the bottom of the slant height would be 6 because it's half of 12. Now I hope you see that there is a right triangle. I'm going to sketch it over here. The right triangle that's created from the slant height and the height is going to be the hypotenuse of a right triangle. So you will need to use Pythagorean theorem to find that length. A squared plus B squared equals C squared, which is going to be our height. This is going to be 64 plus 36. 64 plus 36 is 100. 100 is C squared, so our C is 10, so that means our slant height here is 10. Alright, the next one. This time they want the perimeter of the base, or no, I'm sorry, if the perimeter of the base is 6 times the square root of 2, find the height. Alright, this time it's asking for, and I'm going to kind of sketch what it wants. I don't know if that showed up. I'm trying to use a red pen to help you see that. That is what they want. That is the height. This is the height of your pyramid on this one. Now, if the perimeter of the base is 16 times the square root of 2, now that does mean that 16 times the square root of 2 is all the way around. So 16 times the square root of 2 is going to have to be divided by 4 to get the side length. So look at what happens. 16 divided by 4 is 4. So 4 times the square root of 2 is the length of each side of this square pyramid. So let's label that. 4 times the square root of 2. So if 4 times the square root of 2 is the entire edge, half of that is going to be 2 times the square root of 2. That's going to be the leg of your right triangle. I think I'll sketch that over here too, like I did on example A. We have 2 times the square root of 2, and we have a slant height of 9, and we need to figure out this height, this red line right here. All I did was I took this little triangle that's inside the pyramid and pulled it over here so you could see you are going to use the Pythagorean theorem to solve for your height on this one. So let's let our height be a squared. You're going to take 2 times the square root of 2 and square it, and then that equals 9 squared. Now 2 times the square root of 2 squared, if you're having a hard time doing that in your head, 2 times the square root of 2 times 2 times the square root of 2 would be 4 times the square root of 4, and the square root of 4 is 2, so 4 times 2 is 8. But I'm going to show you how to do that in the calculator. Let me put that over here. Let's see if I can get it to show up. Okay, if you're going to take a 2 and multiply it times the square root of 2, you will need to put it in parentheses if you're going to square it. So I don't know if you can see this, but you're actually using a double parenthesis because you're going to have to square it. So the answer to 2 times the square root of 2 squared is 8. 9 squared is 81. When you move the 8, you subtract 8 on both sides. So you get a squared is equal to, this would be 73. So your a is the square root of 73. That's probably the best answer. If you wanted to go ahead and do a decimal answer, you can. I'll let you leave it either way. The square root of 73 is the answer, or about, let me put it up here. Your height is the square root of 73, or approximately 8.5. And they didn't give us a unit, so I'll just say 8.5. That's your answer. Okay, example 4. If the height is 7 units long, find the slant height. Okay, this one is going to be a little bit trickier because we're going to use the Pythagorean theorem again. Do you see the triangle? This triangle right here inside, the dotted line, I'll just kind of sketch this. The dotted line ends up being the height, and the solid line slanting here is your slant height. So this is your slant height and this is your height. Well, what happens is, I'm going to call this A because this is really your apothem right here. And we need to do that first. We kind of need to figure out that apothem because we can't do the Pythagorean theorem until we've figured out the apothem on this one. Now, the 10 times the square root of 3 means this distance on the edge of this triangle here. Now, they have tick marked this one so you can tell that it is an equilateral triangle. So, I think I'm going to draw that too. Let me grab my, and move this up. Got plenty of room to work this out. But if I were to draw the right triangle here, 10 times the square root of 3 does represent, excuse me, all the side lengths. So, and remember, in an equilateral triangle, when you draw the altitude, you create a 30, 60, 90. My pen's kind of running together, but can you see that? This is 30, 60, 90. That would mean 5 times the square root of 3 would be the short leg of my 30, 60, 90 on both of these. So if this is 5 times the square root of 3, and I need to figure out the, let's see, what are we doing here? We're finding, oh yeah, we need the center point here. Okay. The apothem, remember, just goes from the center down. So we're going to create, this is an interesting one, because you have another 30, 60, 90 created from, I'm going to draw this one a little darker so you can see it. 5 times the square root of 3 is half of the side of this equilateral triangle. So this distance from the center to the perpendicular bisector here is going to be the short leg of a 30, 60, 90. So if the long leg is 5 times the square root of 3, the short leg is just 5. I think I better review that for a minute. Let's kind of draw I'm just sketching a 30, 60, 90. This is on your formula chart just to help you remember. The short leg times the square root of 3 is always the one opposite the 60-degree angle. And then twice that is your hypotenuse. Now you don't really need that for this one. We don't really need this line right here. We really need our apothem right here. So the apothem on this one's 5. Let's go ahead and label that. That would make this apothem of 5. Okay, let's see. Oh good, they did give us the height. It's up here in the words. See how it says the height is 7? That means this dashed line right here. I think I'm going to have to draw an arrow to it. There's too many lines in the way, but if I put a 7 for this height, that means my apothem is 5 and my height is 7, do you see the right triangle here? We're going to use the we're going to use the Pythagorean theorem with our legs 7 and 5. So that's 25 plus 49. 25 plus 49 is 74. If 74 is the value of c squared, then c would be the square root of 74. Let's put that in the calculator and get a decimal answer. So it's approximately 8.6. And they didn't give us a unit, so we'll just say units. And that would be our answer. That's our slant height. Slant height is 8.6 units. Okay, you might want to listen to that one again. You might want to pause and back up. That one's kind of tricky. My hint on this one would be to first find the apothem. That's kind of the, let's write that down. This is really the trickiest part of this one. I'm going to put an arrow, put a couple of stars here. Find the apothem first. Okay, we're going to have to do the same thing, I think. Let's see. Yes, on the next example. You know what? I'm going to draw a line on this to keep these separate. I'm trying to make this neat. Okay. Alright, look at example, the second part of example 4. The perimeter of the base is 36. So if 36 is the perimeter of your equilateral triangle, perimeter, remember, means all the sides around. So to find just the side length, you need to take that perimeter and divide by 3. So 36 divided by 3 means our side length is 12. Let's go ahead and label 12 for our side length. Now remember, when you draw the slant height and this little apothem right here, especially on this equilateral triangle, it is going to cut this in half, so this is only going to be 6. So on our, let's look at this for a minute. 6 would be, you know what, let's do the apothem like we did on example A. Okay, when you have a 30, 60, 90 triangle, I'm going to kind of draw, oh, let me move that up. Let's kind of sketch this darker in here so you'll see it. 30, 60, 90 is our, if you think of this, this right here is my base. And each side length is 12, so that makes this piece right here 6, if these are all 12s. Remember, all the way across is 12. So that little piece is 6. Now if you take 6 and you divide it by the square root of 3, you know, we could rationalize the denominator, but I think I'm going to make this a little simpler, and we're just going to use the decimal. So if you take 6 and you divide by the square root of 3, that's approximately 3.5. So this little apothem is about 3.5. So if 3.5 is your apothem, let's label that on our, let's go back to the pyramid and label that up here. This apothem is 3.5. Now you have a 3.5 apothem and a hypotenuse that's 8. I'm going to sketch that little triangle like I had, so you'll see that too. Your triangle now has an 8 for the hypotenuse and a 3.5 for one of the legs. And right now we're trying to figure out this height. So it's very similar to the one we just finished. We are going to use the Pythagorean theorem. And this time we don't know the legs. So let's let our height be one of our legs. And our 3.5, our apothem, is the other leg. And 8 is the hypotenuse. So on this one you're going to get, oops, sorry, that's a plus sign. 3.5 squared is 12.25. 8 squared is 64. To solve for your h squared, you're going to need to subtract 64, subtract 12.25, which is 51.75. Always take the square root of that number to find the value of the other leg. So it's approximately, my calculator is saying 7.19, so we'll round that to 7.2. So that would be the height of your pyramid. These can be kind of tricky. If you want to bring these up to me and let me kind of reteach these to you, we can find one in your notes or your worksheets and work one of these together, because these are a little bit tricky. They review 30, 60, 90 triangles. They review apophthegms, Pythagorean theorem. They're very good problems, but can be a little tricky. So come see me if you need some help.